Hey everyone, welcome to the new episode, the new lesson. In this lesson, we're going to be going back into that process theory, the kernel talking, and all that complicated jumble stuff that we were talking about. And we're going to try to make some sense of it. I'll explain it the best I can. And of course, if you have any questions, you want some clarification, please feel free to reach out because this stuff is a little bit confusing. And let me draw it out. I'm a terrible drawer, so I apologize. But let's say we have a CPU, okay? And the CPU has 4 cores. And each of these cores have a thread, or maybe 2 threads. And by the way, these threads, it could be like one real thread, and then maybe 1, 2, or even 3 kind of hyper threads, which is like a virtual thread processor thing, I guess. And why does this matter? Well, every single process that we're running, by the way, these are all the threads. So every single process that we're running, the PWD, or if we're running bind, or if we're running Nano, or Firefox, or Google Chrome, or some game, or a web server, a mail server, if we're running security settings or Nginx server kind of thing, every single process is fighting over these resources. These are the resources that the processes need to get processed. And the kernel that sits on top of the CPU, the kernel that sits on top of the CPU is essentially like the core of the Linux operating system. The kernel decides which of these processes is going to get the CPU and when it's going to schedule it, and which ones are going to be running simultaneously. Maybe you have 2 or 3 or 100 processes running all at the same time, but they're kind of scheduled in different, so they're kind of like on and off and running, and that's where we get into the different states of processes. So one example of a process that's not really using a lot of process resources is something that's waiting for an input for like a keyboard. It's like you have that input that's saying press the any key. I'm sure you've seen that before. So that's a process that's running, okay, but it's kind of like hibernating almost because it's not doing anything except for just enough to keep running and not to turn off. And it's just waiting for you to put in your input so that it can then continue its process. So it's kind of just like a process on hold when it's waiting for you to put in the any key. Or remember that one time when you were a kid and you installed Diablo 2 on CDs and it says insert CD 1, then you got to insert CD 2, insert CD 3. Well, when Diablo is installing on an old Windows XP computer, it's doing a lot of processing on the first CD, because it's installing everything that it's reading on that CD onto the computer, and that takes a lot of processing power. But then all of a sudden it reads everything on the CD, and now it's asking for CD2. Well, the process hasn't stopped, because if it would stop, the entire installation would be canceled pretty much. So it's kind of on hold until you put in that next CD. And that's an example of a process that's kind of just like sleeping, I guess, is one way to put it. It's waiting for the next thing in order to continue running so it can finish. And then, of course, same thing when you put in that process to let it keep going, then it's going to go back to using a lot of CPU until it needs the next CD. So that's like an example of, I hope that's making sense. So as we just discussed, there's a type of process that is kind of like waiting for an input, and it's kind of dormant. It's not really using a lot of processing power because it doesn't have the information to keep running. But sometimes there are processes that have all the information to run, but now it's just waiting for the kernel to schedule it to put into action to make sure that process can run. And in order for that process to run, it's either determined by 2 things. Either you, the user, the sysadmin, decides to run a command which runs that process, or you can run a different command, or or there's already a process running that requires that other process to be run to complete running, if that makes sense. So it needs, sometimes some programs or processes need multiple other processes to run to give their outputs into the original processes so that it can finish running with all that information. So let's edit a file, vi states.txt. There are 4 states that a process can be in. The first state is runnable. This is something that is eligible to be scheduled by the kernel to run. It's ready to run. Just needs to wait for its turn for CPU time. And the other state is sleeping. So a process could be sleeping, and this is when it's waiting for something. So this could be waiting for input, or waiting for additional information. That information or data could be like a CD or something extra, maybe an output from a different file. A state could be what's called a zombie state. And a zombie process is a process that has finished running, probably successfully, and it's waiting to be able to give its output to where the output is being requested from. And maybe whatever is requesting it isn't done yet, and it's not ready for that output yet. As the origin of the requester may not be ready for the output that the zombie process is trying to provide. Okay, the 4th state is stopped. So a stopped process is a process that stopped in the middle of doing something. So it hasn't finished yet, and it just stopped. And maybe it stopped because it needs another process to keep going, or it needs some output or some information that it doesn't have, or maybe there's a corruption, or maybe something's happening here that is making it stopped. Or maybe in the last couple videos we talked about signals, like process signals. So here maybe another process sent it a stop signal automatically to stop it because maybe it doesn't need it for whichever processes it's running. It could be stopped by a signal, and could be waiting for continue signal to continue the process to finish. So why is this information useful? Well, when you're troubleshooting, maybe you have applications that are running slow, maybe your bandwidth isn't running correctly, maybe there's too much resources being used by processes and you're not sure what is using it. Well, if you have a lot of zombie processes, then it's an indicator that the parent process that spawned all its children processes is, well, now the children have all completed their work and they're trying to return their output to the parent process, but the parent process, for whatever reason, is not ready to accept their output. Therefore, all those children processes are waiting, and they could possibly be waiting endlessly because the parent process might have hung up on something, and that gives you a starting point of where to troubleshoot. where to start looking. And then, you know, if we hit escape, do semicolon WQ to save this, we can go back into HTOP where we can monitor some of these processes. And here we can kind of see what's using up all of our CPU, what is kind of dormant and just sitting around. Now, if you don't already have HTOP, you can just install by doing sudo apt-get install HTOP. Alright, we can go back to HTOP, and the cool part about HTOP is if you hold down the arrow keys to go right, you can scroll all the way, because some of these get pretty long. And you can go down, you can go up, you can sort it by CPU, by time, by command. You can sort it by the niceness and the priority and user, the process ID. And the cool part is, from here, we can send those signals that we were talking about in another video. And in order to do that, we can test it out on, let's say, Firefox. Let's open up Firefox, sort it by memory. And yeah, right here. So we got Firefox running. Alright, so at the bottom you can see there's different shortcuts. You can raise the niceness or lower it. You can sort by or filter. You can do different setups. There's a help. And there's F9 for kill. But if you actually press F9, then it doesn't do the signal kill default. It actually asks you what you want to do. So we can do sig terminate, which is the default. If we hit enter, then as you can see, that process is gone and Firefox is closed. We have to open it back up. And then of course niceness, just to recap on what niceness is, I believe I already covered it in one of the earlier videos, but niceness is the level of priority that a program has. So earlier when I was drawing those horrific images of the CPU and the processes fighting over CPU threads, well, the processes that are really nice will just give up their CPU time for the not nice, like the meanies. The meanies are just going to hog the CPU power. Like the -11, this one is always going to get the process time before any of these other ones, because this one is lower, it's not as nice, and these ones are nicer, so they give up their resources for the meanies. So let's go deeper into nice. Alright, so there's a command. We could do man nice to find out information about it. And there's a -n, which is adjustment. So we could check it out. What if we want to adjust the niceness on something? We do nice -n, and then we put in a number. So it could be anywhere from -20 to, I think 19 or 20 is the highest. You'll have to check on that. Do some Googling of what the range is, but -20 is the lowest niceness. And that means the lower the number, the higher the priority. The higher the number, the lower the priority. So it's kind of backwards. But because, yeah, the more nice you are, the more you're going to give up your resources for the not nice people. Or the not nice processes. So a niceness of -20, if I were to give a niceness of -20 to a process, that process would probably start freezing up your computer because all of the processing power would be given to it, like all of it. And if I were to give it a niceness of, let's say, 15, it will probably be very deprived of any kind of processing. It's very low on the list of priorities to be scheduled in for that CPU time. So why is this useful? Well, let's say you were implementing a new process onto your Linux system, but your Linux system is in production and it's already running a lot of important things on it, and you don't want your new process to be taking charge of all those processes and stealing all the resources, because it can really hinder the performance of whatever applications are running, which could be business impacting. So, you know, whatever you put in a new process that you're either trying to test, or if it's not that important, you can put in like a high niceness level so it doesn't interfere that much with anything. And then of course you put in the location of process file path, you know. So this would be the program that's running, and of course the program in this case would be file path, and this is the location within all the folders of where that process is located. Alright, and if I enter, it's not going to work because that doesn't work. Another way to change the niceness is going re-nice, so it's re-evaluating the niceness, and you could do -5 for, or -5, and then you could put in the PID number. So let's try that. Let's open up HTOP and find Firefox. So I got Firefox right here. The niceness is 0. And the PID of Firefox is 10.813. Okay, so 10.813. I could do re-nice 10.813 and give it a niceness of, let's say, 15. Oh, oops. I got the syntax backwards. So I wanted re-nice as a 15 of niceness to this. Alright, so this means that this is very nice. Our Firefox is going to be really nice, and it's not going to get a lot of CPU power. And as you can see, it's pretty slow. It's still loading. It just finished loading. Alright, let's look up tacos. And it's pretty slow. Like, it's a web page loaded in like 5 seconds. And it's scrolling very slow, it's very janky, and that's because we increased the niceness, so it's not really getting any CPU power. It's not getting the juice that it needs, right? So let's kill it. Kill 10.813. Bam, done. And another way to do this more conveniently is go to HTOP, let's open up Firefox, and we could hit F3 to search. So let's go search Firefox, FIR, it's already highlighting it right there, and then we can do F7 to raise the priority, or sorry, F8 to raise it, raise the niceness, sorry, and then so yeah, really cool, it's up at 19, the niceness level. And if I hit F7, yeah, okay, F9, let's kill it. Alright, great, so just a quick recap. We talked about niceness, we talked about the different states that process can be in, we talked about how to monitor, how to manage processes in HTOP, and yeah, so it was a little bit of fun. It might have been a bit stressful. Might have been a little bit confusing. If you have any comments or questions, please do not hesitate to reach out. I know this lesson is a bit convoluted and confusing, so please don't hesitate. So I'll see you guys on the next lesson.